For millennia, we have gazed up at the cosmos, asking the biggest questions of all. Where did we come from? Are we alone? Yet, one of the most profound mysteries isn't out there among the stars, but right here, inside our own heads. What is consciousness? This inner universe of thoughts, feelings, and awareness is something we all experience, yet science struggles to explain. We know our brain is made of atoms, obeying the laws of physics. But how does this collection of wet biological matter generate the rich tapestry of subjective experience? How does it create the feeling of being you? It's a question that has baffled philosophers and scientists for centuries. Now, a bold and controversial idea is emerging from the strangest corner of physics. This idea suggests we've been looking in the wrong place. Perhaps the answer isn't just in the classical world of neurons and electrical signals, but in the bizarre, counterintuitive realm of the quantum. Quantum mechanics is the rule book for the universe at its smallest scales, the world of electrons, photons, and atoms. Down there, particles can exist in multiple places at once, a state called superposition. They can also become mysteriously linked or entangled so that the fate of one instantly affects the other, no matter how far apart they are. It's a reality so strange, it seems like science fiction. So what happens when you apply this weirdness to the human brain? You get the concept of quantum awareness. This theory proposes that our consciousness isn't just a byproduct of complex computations, like a super advanced computer. Instead, it might be a genuine quantum phenomenon. The idea is that our brains might have evolved to harness these delicate quantum processes. Could your thoughts be a symphony of quantum superpositions? Could the feeling of a unified self arise from a vast network of entangled particles, connecting different parts of your brain into a seamless whole? This is the grand and perhaps audacious proposition of quantum consciousness. This isn't just a new idea. Back in the 1990s, the brilliant physicist Roger Penrose and anesthesiologist Stuart Hameroff put forth their orchestrated objective reduction theory, or ORCH-OR. They pinpointed tiny structures inside our neurons called microtubules as the potential stage for this quantum drama. They suggested that quantum computations happening within these microscopic tubes are what give rise to moments of conscious awareness. At the time, it was a fringe concept, a fascinating but unprovable flight of fancy. But as our technology advances, we are finally developing the tools to peer into this hidden world and ask, could they have been right? Science doesn't stand still. An idea that was once pure speculation can become a testable hypothesis with the right tools. And today, we are building those tools. The world of quantum computing is exploding with progress, giving us unprecedented power to simulate and interact with the quantum realm. This has reignited interest in the search for quantum effects in the brain. For example, Hartmut Neven, who leads Google's Quantum AI Lab, has made a fascinating proposal. He suggests we could use their next-generation quantum processors, like the one recently unveiled and named Willow, to directly test some of these theories. Imagine an experiment where a brain is linked to a quantum computer to search for signals of entanglement. We are on the verge of moving from what if to let's find out. The excitement isn't just happening in corporate labs, it's also buzzing in academic circles. A 2024 study from researchers at Shanghai University offered a new theoretical pathway for quantum connections in the brain. Their mathematical models suggest that the myelin sheaths, the fatty insulation around our nerve fibers, could act like tiny quantum cavities. These sheaths might enable the creation of entangled pairs of photons, particles of light, that could then zip across the brain, linking distant neural networks. This could be a physical mechanism for the brain-wide synchronization we see during high-level thought, a kind of quantum internet for your mind. It's still just a model, but it provides a concrete, testable idea for experimentalists to chase. This wave of new thinking is also inspiring a new generation of entrepreneurs. A startup called Nirvanic Consciousness Technologies, founded by quantum computing pioneer Suzanne Gildert, is on a mission to build conscious AI. Their goal isn't to create a machine that simply mimics human intelligence, but one that possesses qualities like intuition and genuine awareness. They believe that by building AI based on the principles of quantum consciousness, like the ORCH-OR model, they can create systems that are safer and more aligned with human values. This represents a powerful convergence of neuroscience, quantum physics, and artificial intelligence, turning a philosophical debate into a technological quest. These developments mark a significant shift. For a long time, the tools simply didn't exist to explore these questions. We could only theorize and debate. But now, with powerful quantum simulators, advanced brain imaging, and new mathematical models, the landscape is changing. The search for quantum awareness is no longer just a thought experiment. It has become an active, albeit challenging, field of research. The hunt for clues is on, taking place in the most advanced laboratories on Earth, all in an effort to solve the puzzle of the 3-pound universe inside our skulls. Now, before we get carried away on our spaceship of the imagination, we must anchor ourselves to a crucial scientific principle: skepticism. For every bold new theory, there must be rigorous scrutiny. And the idea of a quantum brain faces a formidable challenge, one that has kept it on the fringes of mainstream neuroscience for decades. The primary objection is simple and powerful. The brain is just too hot, wet, and messy for the delicate dance of quantum mechanics. Quantum states like superposition and entanglement are notoriously fragile. Even the slightest disturbance, a stray vibration or a change in temperature, can cause them to collapse into a definite, classical state in a process called decoherence. Think of it like trying to build a complex, fragile ice sculpture in the middle of a bustling, warm train station. It's a chaotic environment. The brain, with its constant electrical signaling, chemical reactions, and warm temperature, seems like the worst possible place for quantum phenomena to survive. Most neuroscientists argue that any quantum state that might form in a neuron would decohere almost instantly, long before it could have any meaningful effect on our thoughts or actions. From this perspective, the brain's operations are perfectly well explained by classical biology and chemistry: neurons firing, neurotransmitters binding, and complex networks processing information. There's no need to invoke the ghost of quantum mechanics. For the mainstream scientific community, consciousness is seen as an emergent property of classical computation. Your brain, in this view, is an incredibly sophisticated biological computer. It has about 86 billion neurons, each connected to thousands of others, forming a network of staggering complexity. The combined activity of this network, processing sensory data and internal signals, gives rise to awareness. It's a product of complexity, not quantum weirdness. Proponents of this view argue that we don't need a mysterious new physics to explain the mind. We just need to better understand the immense complexity of the neural architecture we already know is there. This skepticism is not born of a lack of imagination, but from a commitment to evidence. To date, there is no direct, verifiable experimental proof of functional quantum effects in the brain. The theories from Penrose and Hameroff, as well as the newer models, remain just that: theories. Until an experiment can definitively show that a quantum process like entanglement is not just present, but is actively being used by the brain for computation, the broader scientific world will remain unconvinced. The burden of proof lies with those who propose the quantum explanation, and it is a very heavy burden indeed. So, where does that leave us? On one side, we have a tantalizing grand vision of a quantum mind, a theory that speaks to the deep mystery of our own existence. On the other, we have the sober, evidence-based skepticism of mainstream science, which points to the immense challenges and lack of proof. It might be tempting to dismiss the quantum theories as mere fantasy, but that would be a profound mistake. The history of science is filled with ideas that were once considered outlandish, but later became cornerstones of our understanding of the cosmos. The Earth revolving around the Sun, the bending of space-time, these were once radical propositions. Exploring the frontiers of knowledge, even the most speculative ones, is fundamental to the scientific enterprise. The quest to understand consciousness is one of the most important challenges we face. It forces us to push the boundaries of what we know and what we are capable of investigating. Even if the theory of quantum awareness ultimately turns out to be incorrect, the journey to test it will yield incredible discoveries. In our effort to find quantum effects in the brain, we will inevitably develop new technologies for imaging neural activity, new insights into molecular biology, and a deeper understanding of the brain's computational power. Furthermore, these questions have profound implications for the future of technology, especially artificial intelligence. As we strive to build more capable and safer AI, understanding the nature of our own consciousness becomes critically important. If awareness does rely on quantum principles, as companies like Nirvanic are betting, then simply building bigger and faster classical computers will never lead to true consciousness. This exploration could reveal a completely new path forward for creating intelligent systems that are not just powerful, but perhaps also intuitive, ethical, and wise. The answers could reshape our technological destiny. Ultimately, the search for the origins of consciousness is a search for ourselves. It is an expression of our species' innate curiosity, the same drive that led us to map the stars and decode the genome. We are beings made of stardust, animated by the laws of physics, who have evolved the capacity to ponder our own existence. We do not yet know if our inner cosmos is governed by classical rules or by the strange and beautiful logic of the quantum world. But it is our privilege, and perhaps our purpose, to keep asking the question. The universe is under no obligation to make sense to us, but that will never stop us from trying to understand. The mystery continues.